folks, boys and girls, I guess, and ladies and gentlemen. Today we are gonna study about toxicology, which is about toxic toxins from metals. Since we are studying about metal, definitely we are gonna study about metal. Wait a second, I'm trying to find my marker, which for some reason I'm not able to find. But yeah, let's just go with it. Whatever we have. So first we are gonna talk about arsenic. Then we have our lovely Mercury. Then we have lead, and then we have our also forgot what is it? Mercury, lead, cadmium, the most lovely one. Wait a second. Yes. Also, there is copper overdose, but that's like side character. So yeah, that's actually called antagonism. Okay, antagonism, overflow of metal. Okay, like copper. Yes. Okay. Now you got it. So what does arsenic does is arsenocosis. Arsenocosis. Okay. And our lovely mercury does is Minamata disease. Okay. Minamata. Minamata disease. And our lead does. Lead, forget about lead. Cadmium does Itai disease. Itai disease. Okay. Yeah, I knew this. The pen would not work. Marker, I guess. Whatever. Itai disease. Then we have what does lead do? I forgot. Yeah, anemia. Anemia. Yes. How does it do this? Right. So Itai disease happens because it replaces zinc and calcium. Yo, what's up? Three people in the stream, bro. Welcome to the stream. Really appreciate your visit, bro. Thanks for coming. For real. Yo, nine folks, bro. That's crazy. Welcome to the stream. Thanks for coming. Come on in the chat section. We can yap and interact for real. So, why does lead causes anemia? So, what does arsenic does is it. Oh my god, my pen, my marker, bro. Again is in turmoil. I actually lost one marker, so that's the problem. So arsenicosis is because what arsenic does is it loves selenium and sulfur. Okay. Wait a second, I should recheck definitely. So that I shouldn't give you wrong information. Wait a wait a second. Yo, six people in the stream. Yo, what's up? Welcome to the stream, bro. Come on in the chat section, bro, for real. Come on. So was I correct? Wait a second. Okay, I mixed things up a little. Sorry for that. So That is the job of mercury, which the selenium and sulfur stuff. Okay, so our mercury attaches to selenium and sulfur, or we can say that sulfhydryl group. What arsenic does is it attaches to phosphate. Okay, okay. This marker is also kind of in trouble, so okay. So yeah, where were we? Phos it attaches to phosphate, like it is kind of attracted to phosphate, and replaces pyruvate dehydrogenase, pyruvate dehydrogenase, and reduces, oh sorry, inhibits, it totally stops it, not reduces, inhibits ATP production. Okay, ATP is actually your energy making currency, so it stops that because obviously it attaches phosphate, right? So you would understand that, right? So what happens in Minamata is that it is really attracted to selenium and sulfur, or sulfhydryl group attracted. Okay, high affinity. So it, like it replaces and it attaches to protein. It attaches to proteins and passes through blood brain barrier, and actually it does is brain damage. Okay, attacking central nervous system is your like kidney, sorry, not sorry, I'm really sorry. Central nervous system is your spinal cord and your brain. Okay, so yeah, because they control, like they autonomously control all your like responses, stimulations, like whatever your body wants to do, like even sometimes like reflex action, even your body doesn't consult brain, it actually asks your spinal cord what to do, so that the transfer, data transfer is efficient. So yeah, they both are central nervous system. Then peripheral nervous systems are your motor nerves, sensory nerves, other nerves. Okay. So yeah, sensory nerves is like input, where your stimulations go, and motor nerves is like output, which gives the response actually. Okay, mostly. So attacking central nervous system and kidney. Okay, kidney. Oh my god. So And I was talking about cadmium. It is called itai itai. Itai itai is because it was it was a runoff from rice field, I guess, in Japan. Okay, come on, bro. One person in the stream. Come on, the chat section, bro. So in Japan, by the way, so it means actually ouch ouch. Okay, in Japan. So it replaces zinc and calcium accumulating in bones and also does kidney damage, I guess. Yes, in bones and where can I write it? And kidneys. So obviously, it is accumulating in bones. So your bone becomes weak. So really gives bone pains. So that's what happens. Okay, that is the story of cadmium. And obviously, lead is like same stuff, but it attacks blood more. So it reduces your blood production. That's the thing. So it also attacks your central nervous system. We also call it CNS, brain, and kidney, I guess. Kidney. Okay. Mimicking zinc and calcium, also, I guess. And it inhibits Yo, what's up? 5 people in the stream, bro. Welcome to the stream, bro. Come on, the chat section, bro. What are you all doing, bro? Like, okay, so there are also chelating agents, which actually. Oh, sorry, why I'm writing actually? Oh my god. Which replaces bonds because the bonds of metals which are actually binding and stopping your daily metabolism. That's why the toxicity happens. So to replace that, chelating agents replace the bonds by the metal. Okay, bonds by metal. Okay, so chelating agents are organic molecules which so some chelating agents are EDTA. Okay, a British Lewis agent something BLA. Then there is penicillamine works with copper and okay, something. Okay, just write the example, right? I need to remember it, I guess. But with mercury, I guess DMSA works. So yeah, also I have to tell you lead pollution where it happens. Sources pollution. How lead pollution occurs? It happens from your uh, corroding plumbing pipes. Plumbing pipes. You can understand the further stuff. And old paints. Old paints. Lead paints actually. And aviation fuel, your aeroplane fuels, aviation flight fuels, whatever you see that, airplanes fuels, those fuels. Then we have smelting, like industrial runoffs and smelting and all. Smelting. Then we have. I remember other one. Smelting. Yeah, I guess this much only is there. Like four are there. Yo, Trent Bars 1496 says, hi, what's up? Welcome to the stream, bro. Thanks for joining. Really appreciate your visit, bro. What's up? And Trent Bar 1496 says, angry, sweaty, victory pose, whoo whoo, and oh, scary. Some emojis which he also is confused, like which to choose. So he has given some emojis, I guess. So yeah, so this gives the lead actually reduces your blood production, and cadmium actually does bone pains because you have osteoporosis. Osteoporosis is like, let's say, your bones are weak because your bone should be like a tight knit structure, like a cloth. Let's imagine a cloth. If there are much more holes in it, obviously your cloth won't be like, let's say, a wooden bar, like a wooden log. If there are way too much holes in it, would it be strong enough? Because obviously it can break because there are faults, there are breaking points. Like that, your bones are replaced, like instead of zinc and calcium, they are replaced by cadmium, which is not suitable for it. And then obviously your bones will break easily because there are holes in it. So osteoporosis, that's what happens. So that's why it is called itai itai disease in Japan. Itai itai means ouch ouch, okay, in Japanese, in Nihongo, okay. And in Mercury, it is actually called Minamata disease. I have wrote it. And arsenocosis, there are also some points, I guess. Actually, it inhibits ATP production by binding with lipoic acid, okay. I forgot to write that. Binding lipoic acid. Like this part is important, like which it inhibits, like pyruvate dehydrogenase, but let's just keep it mind also this, like how it does that, okay. So yeah, it reduces your respiration, so your energy production goes into all-time low. So that's how every problem starts. And mercury is, yeah, so mercury is attracted to sulfhydryl group. And there might be chelating agents also. I think I have covered most of the points, right? So the one of the chelating agents, like, yeah, also yeah, I have wrote it. They replace the bonds made by the metal. So yeah, that's the most of the thing like we have. Uh, so this is cadmium is from runoffs. Lead pollution. I've said mercury is from, I guess, industrial runoffs. I guess mercury is also from industrial runoffs. Maybe. So also lead antidote is also like, so this mercury, whatever antidote it is, it actually replaces the sulfhydryl group. And lead, it makes it water soluble. Yeah, I can write this too. make water soluble to pass it through urine. Okay, water soluble so that it pass through urine. It can do that too. Like it should just remove it. Okay, anyhow it can do that. So that's not our look up like how it does it, but yeah, it does that. So yeah, ATP production is stopped means obviously Krebs cycle stop. Krebs cycle stop means reproduction stop. Sorry, respiration stop. What am I saying? Yeah, sorry. I'm being confused in just R words. Oh my god. So our lead does is wait a second. Yeah, cadmium does. It is also called hematological damage, emotional damage. Okay. So hematological means kidney. Okay. Right. Right. Also, our cadmium is also cadmium not mercury is also called as neurotoxin because it attacks your central nervous system like your neurons. Neurotoxin. Okay. Also, oh sorry, it is not BLA, it is BAL. Okay, BAL. Okay, I have also not completed this. This is penicillamine. Okay, and there is uh di something DMSA or something like that. DMSA, yes, I was correct. Yes, there is DMSA, and also it is British anti-Lewis. Uh, wait a second. Wait a second. British anti-Lewis acid, I guess that it is, and yeah, penicillamine replaces the sulfur stuff, right? It binds to the sulfur, like sulfur, phosphorus or something, so that it doesn't stop the production of the like metabolism. It shouldn't stop. So basically, what happens is toxicology replaces bonds to stop metabolism. Okay, stop metabolism. That's how it becomes toxic. If metabolism is not there, obviously you would not be alive. Simple stuff. And maybe I should zoom out and you should take screenshot or notes or something. Yo, okay. Yes, you can see this. Okay. Thanks for watching. Like, share, subscribe. See you next time. Bye. Right. Alright, let's go. Wait, where's my focus? Yes. Yo, what's up? 4 people in the stream, bro. Welcome to the stream. Come on, the chat section, bro. Like, I'm gonna go, but yeah, we can talk if you want something, you want to ask something, tell something, yap something. So, also, I have to like tell the pollution sources, which I actually forgot. Yeah, I have to tell you some sources. Like I have told about lead, cadmium is industrial runoff. Like how it happened. Like there is also electroplating stuff, but yeah, who cares? So 1, 2 is more than important. It is the mercury is mostly spread in water, seafood, everything related to sea or water. Okay, mercury is polluted, like how you get it. Then there is arsenic is from pesticide and groundwater. Obviously, if you are using pesticide, then obviously it would go in the ground and it would pollute the groundwater. Like pesticide is used in crops, right? So it would enter the ground and it would seep through the soil, and obviously it would enter the groundwater level table. So yeah, it would come through your wells and whatever, like your method of drinking water, where you derive it from. So that way it's gonna come anyway, and it's gonna make you sick. That's how it happens. So thanks for watching. Bye. Like, subscribe. See ya next time.